explorers, and welcome to another video. Today we are going to tackle day 12 of Advent of Code, but first I want to thank Jay Neswar, which is my latest Patreon supporter, which has now access to the private Discord, and I'm really happy to be chatting to him. So let's just jump right into this. Day 12, Passage Pathing. With your Submarine, Subterranean, Subsystem, Subsysting suboptimally, the only way for you to getting out of this cave anytime soon is to find a path yourself. Not just a path. The only way to find the best path is to find all of them. Unfortunately, the sensors are still mostly working and you build a rough map of the remaining caves. Your puzzle input. So here we have a little puzzle input. This is a list of how all the caves are connected. You can start at the cave named Start, and your destination is the cave named End. An entry like BD means that the cave B is connected to D. That is that you can move between them. So the above cave system looks like this. Your goal is to find the number of distinct paths from that start at start and end at end, and you don't visit small caves more than once. There are two types of caves: big caves, written in uppercase like A, and small caves written in lowercase like B. It would be a waste of time to visit all small caves more than once, but big caves are large enough that it might be worth visiting them multiple times. So all paths you can find should visit small caves at most once, and can visit big caves a number of times. Given these rules, there are 10 paths through the cave system. Each of the line above list corresponds to a single path, and the caves visited at that path are listed in the order that they are visited and separated by commas. Note that in this cave system, cave D is never visited by any path. To do so, cave B should be needed to be visited twice, once on the way to cave D, a second time returning from cave D. Since B is small, this is not allowed. A slightly larger example has 19 paths, and then an even larger one has 226 paths. And the example that they gave was even larger, so it would have 10,000 paths or so, but I don't think there is a million paths. Famous last words. So I will try to handle this with a lot of classes. So let's go back here, and we will create a new package that we call, and we are back. I think it was the dashing cave project that was the problem. Can't really have a dash in something that it's dotted. So let's call this a cave, and we have a path. And the path, we should have something that is a set of strings only visit once. So these are the small caves, so we can call them small caves. Visited. Visited small caves. New hash set. So that's one thing that we need here in our path. And we also need to have string last visited. So that's the last point we visited. Let's do private here. Boolean at the end, false. We can have a public path, where we create a new path, and this could have a set of strings, visited caves. So I think we will set these to final. All of these. values, because these will be something that we set in our string last visited. So here we will have visited small caves is a new hash set. Visited small caves. We will add the last visited. This last visited will be last visited. And if end is equals to last visited, then we are at the end. So that would be pretty much that, right? And we only want to add to small caves if last visited to lowercase is equal to last visited, or is equal to last visited. Because I don't think that we have a last visited is lowercase, right? No. So if this is lowercase, we will add it to small caves. What's the problem here? Might not have been. Yeah, it's initiated here. The first thing we do. Oh, this. Of course. Great point there. So now we have a way of progressing forward here. With our path, we need to have is at the end. We need to have a get last visited. And that's pretty much it. We also need to have a public boolean have been at, and then string cave, and if visited small caves contains this cave, then we have already been there, so that's not allowed. And I think we can build in this little function here. If cave is lowercase, then we return that value, else we return false. So we don't need to have any idea if it's a large or small cave. So that is pretty much our cave system. Then we need to have I don't know if we need to have that as a single class, but we need to have all the paths that is visitable, all the cave and cave transitions. So let's do a hash map of string and then a set of string new cave transition new hash map. That's all the cave transitions. And when we read in a line here, then we will, so for each test split, we will also split the line on dash. And that will be our string line array. Let's not do it more complicated than that. And here we take that line array and check if it contains the key. Line array 0. If it contains that key. If it not contains that key, and we also want to do the same for line when. That's the problem here. It's always true. At the moment it is. Cave transition put. This. And a new hash set. So if we haven't seen any of these endings yet, we will create a new hash set. If cave transition, I believe that the end will always be on the right hand side and the start will always be on the left hand side. So if this one is if start equals this first cave transition here. No, I don't really need to do that because I can't move back to start again. That's not a thing. So I can have a cave transition back. All of them can be back and forth. And so let's just add these. So cave transition, get line array 0. Here we go to 1, and then here add line array 1. And now we need to have one cave transition that goes in the opposite direction, like that. So let's create a little system out here, just to have a hold where we can put our breakpoint, and we need to run the right day, of course. So let's do that. Day 12, and let's do this one. So now we have cave transitions. We have start, which only goes to A and B. Is that correct? We can go up here. So start can go to A and B, correct? And then we have A, which can go to 4 different directions. Can go to B, C, D, yeah, C and start, and also end, yes. And then we have B here. Yeah, it can go to D and can go to A, it can go to start and go to end, yeah? So I think that we have a good cave transition map here. So what I want to do is to create a list of path in the cave, new all paths, new array list. Or should we do a set of all paths? Oh, I don't think that would matter. Let's see here. While not all at end. What a good boolean. Boolean, not all at end. False. Not all at end equals to true. So let's see here. We have all the paths, but we want to create one new path here. We want to add a new path, and that path, should have a new hash set, so no visited paths yet, and last visited should be start. So that's our starting point. And then for all paths, we will do something. If p is at the end, then we will continue. Else here, not all at end equals to false. Let's see here. Not all at end. That should be true. False. True. So, so now we have figured that one out. Yeah. And if we aren't at the end, we will have the get last visited. We will have our cave transitions when we will get that last visited. And this in turn will be a set. So we should have a for loop of this string set for all the caves that we want to visit. And get all the small caves, of course. So here we want to go through all the paths again. Let's see here. We have this cave transition that we want to go to. And yeah, we want to take this path and see if we have been at this cave. If we have not been at that cave, we will visit that cave. So we'll create a new path. So I believe that we'll have a new list of new paths, array list. So that's the new paths that we will have after this. And all paths will be equal to new path. So we'll switch it there. So here we can say new path, add a new path, and this path should have all the old paths, all the old visited caves, and the new one, like that. So that's pretty much it. So let's see what's happening at the first iteration here. What? Can't we be there? Let's go there then. Can't be there either. What? Oh, it was because I already was debugging. So let's go to the first part here. So let's see here. With the new paths, we had two new. last visited A and last visited B, and they are beginning at start. That looks very promising. Then we have a couple of new ones here. Last visited B, last visited C, and so on. So let's go down here and see what the end result was. All paths equal to 0. That's not what I wanted. If this path is already at the end, we don't want to remove it. We just want to add the old path to the new array. So let's see here. So now all paths are 10. So 10 different paths through. And I believe that that was what we were expecting. So that's very good. All paths size. So now we can just print out the size of all paths. And that is 10. Which is extremely well. Extremely well done, sir. So let's do a little bit of a harder one. Okay, so here we have one of those where the start is on the wrong side. Yeah, but we don't care because we didn't take that into account. So we put in this little larger example here and started off. We got 19, which was the right answer for that one. If we take the little bit larger one here, put that in, we got 226, which is the right answer. So that means that we might be able to just take the data set, the large one, and run that too, and get 5,178. If we put that in here, you get a gold star, I get a gold star, everybody gets a gold star. We solved it. Right. After reviewing the available paths, you realize that you might have time to visit a single small cave twice. Specifically, big caves can be visited any number of times and small caves can be visited at most twice. The remaining small caves can be visited at most once. A single small cave can be visited most twice, and remaining small caves can be visited most once. However, the caves named start and end can only be visited exactly once each. Once you leave the start cave, you may not return to it, and once you have reached the end cave, the path must end immediately. Now there are 36 possible paths through the first example above. A slightly larger example above has 103 paths through it, and the even larger example has 3,509 paths through it. Okay, how many paths through these cave systems are there? Okay, so one of the caves we can visit twice. Let's see here. I think this is just a path issue. So let's go back to the test data here, and like that, and we will take the really small example first and get that squared away. So let's try that with our test data here. Let's see. Oh, didn't I copy it? Copy. Paste. So there we have the really small data set. So in the path here, we check if we have been at, and last bit to the lowercase, yeah, and we add to the small caves, which is fine. We can add multiple times to the small caves. That's no problem. private string multi-cave. And that should be null. So, have been at, if this has been the case, and if multi-cave is null, then we want to have a special case here. If visited, then multi-cave will be this cave. Else return. Let's see here. We have this. Yeah. So else return that, which we already do down here. So here we will return false. So if multi-cave have been there, we will set that cave, and then we will not do that again. So if we do that, yeah, we can do that because if multi-cave is null and start is not equal to cave and end so none of those should be true as well. Let's do some organization here. So none of these can be true. But like that. Really good that they tell you that that could never happen. So if none of these are true, then we can do that. What do we end up with then? We end up with something that takes forever to run again. We are doing the test set. So let's see here. We go here. Yes. We are not at the end. So let's go here. B. Multi-cave is null. If we have visited B, so do we ever end up there? There we end up in this specific case where we have B. Wait a minute. We need to have this propagated. String multi-cave, of course. And we can put that as our first thing as well. Of course, and then we need to have one get multi-cave, and we need to have here when we create, we need to get the multi-cave and put that into the path as cost. Or else we will never propagate that value to our new objects. Yeah, so the multi-cave here is null. Or the multi-cave could be start. It doesn't really matter on the start object because so let's see here. null. There we had a multi-cave. Then we weren't. So let's see here. So that has ended. This don't have any multi-cave. That one has ended. And that one has ended. I would like to see at least one that has a multi-cave. None of them have it. Didn't I set the multi-cave up here? No, I didn't. This multi-cave equal to multi-cave. Buggy. 29. Is that correct? 36. So that's not correct. So do we have an example here? We have one example, right? Yes. And let's go down here with all the paths. Yeah, remove that one. There we go. So we have 29 paths. We only do a difference if, and we can even do this. And if that is the case, we will return false, because we haven't visited that cave yet. And after that, we have visited that cave. And we get 29. Let's see here. Private string path string equal to nothing, and here we do this path string is equal to path string plus last visited. Plus an extra comma. So, and then we go here and do string path string. Add so much things. Get path string. So here we'll p get path string. And I think now that we have done this so many times, I think we should have a public path with a path p and then the last visited up here. So add one more. And then we can have one that is just those two. So everything up here will come from this one. P get multi-cave or P multi-cave. P p path string. We can remove these getters because we don't use those anymore. And we also want to do all of these, of course, in this path. Let's see here, we have the first one where we remove this null value. That will be correct. And here, down here, we will just say, I want to give you the current path and the next part here. So here we can do p and last visited is something that we add to. Yeah, I think that is what we do. So then we don't need this one either. If we run that through, and down here we will have a for loop of path p all paths, and then system out print line p get path, let's call it that, path string. Down here we will have one get path string. So now we should be able to print out all the results. And we have a bunch of these, but we don't have the start value. Why don't we have the start value? Because we have the last visited start up here. Oh, wait a minute. Yeah, of course. We want to do that here as well, but we only have the last visited. No, don't. So now we have all the paths that we think are correct. So let's go through these and see what we are missing. So here we have a bunch that I have not visited for some reason. And the result was 36. So these are all the ones that I've been missing. And the one that I've been visiting twice is B, right? So why don't I visit B again when I end up in... Is it that I have been... Good question, good question. But I think we should be able to find the first one here pretty easily. So if we go here, we should have one that is this first part here. When that is available to us, then we should be able to. And I think we also need to say that a toString of this one is just path string. I don't want anything else. Yeah, it can be like that. So we could do it like this. We have two paths. And continue. A bunch more. And what we are looking for is A, B, A, C, A. A, B, A, C. A, B, A, C, A. So that's one that we want to look into. When we use that one, why don't we get the new values there? So here, if we go here now, then we should have A, B, A, B. And there we have A, B, A, C, A. So this one. If we now get a B in this cave here, so this one should be allowed. So here multi-cave is already B. How is that possible? So we need to go back and look at the paths again here. So now we have those. Now we have A, B. This should not have a multi-cave. Yes. And if we go to the next one, ABA. So that has a multi-cave of B. That means that that has a multi-cave of B as well, of course, because those are the same object. That's no good. That's no good. Yes, of course. So, we'll have a found multi-cave. And we will set that here instead. Then we'll have a get found multi-cave. Like that. And we need one more of these. String found multi-cave. Now we will do this path last visited. Multi-cave is equal to found multi-cave. So there we will set it eventually. And here, if P no, that doesn't work either. Oh my god. Yeah, so that could be still it. But we need a different function here. Get multi-cave. And that will have is multi-cave. Yes. let's see here. And here we'll return true, else we'll return false. So here, if P is multicave, then we will do that, else we will do that. And here we should add C to the multicave system. Let's see what that does for us. Did we get 36? We did get 36, so that's good. Because if we are handling the same thing, then the current path we have here would have the multicave in it, and then when we added other multicaves, that would just add to that one. So we would destroy this immutability that we had. So now we had to first check have we seen this before, and if it's a multicave, then we need to add that. But it will not be a multicave if it's not valid. So let's see here if we take the little larger example here. So the values we are looking for is 103 and 3509. So with this example, it should be 103. Let's see, that's 103, and the little larger example here should be 3509, which looks reasonable as well. So let's do the full list eventually here. So let's go over to the data set and see what the result will be. And we get 130,094. So let's see if that is the correct value. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So let's see what we did here. We had, first off, this cave transition, where we went through the full data set and took each part where we went from one cave to another cave. And then we will create transitions, so we have both the path from that cave to another cave and from the other cave back to this cave. So we have both directions here, and we put that into a long hash map of cave transitions. Because we are using sets up here, we will not get any duplicates in either direction. And then we will create a list of all the paths that we want to visit, and we will put in our start path into the list, and then we will go until we have found all the paths that end in the end. So if we end up in the end, then that's a good path, and when every path has ended at the end position, then we are done. And here we will create a new list of paths, so we will only keep the ones that could progress or is already at the end. And first off, where we go through all the paths and realize that we have some that already reached the end, we will just put those back into new paths. And then if this is not one that have reached the end, we will set this value to true. So we will continue this while loop. And then we will go through each of the cave transition for the last visited cave for this specific path. And if we have been there, or if we haven't been there, then we will check if this is a possible multi-cave position, which means that we have been here once, but not twice, and we haven't been twice to any of the other small caves. Then we will add the information about this cave as a multi-cave, and also the last position and all the other things in this path. Or else we will just create a new path with the last position here. And then we will set all paths to new paths and then reiterate on the next one. We have some debugging here where we'll print out all the path strings and also the path size. If we look at the path, we have different values here. So first off, we have a bunch of constructors. And first, we have a bunch of data, of course. We have the set of all the visited paths. So no duplicates here. We have last visited. And if we are at the end, we have the multi-cave information for that single one small cave that we can visit twice. And also path string for debugging. If we want to set this specific multi-cave, if we have found one of those, so this was the line that we had up here where we had 3 arguments, so the path, the last visited, and the multi-cave. In that case, we will run the standard constructor and then add the found multi-cave. Otherwise, we will have a constructor which takes the last path, add last visited to that path, and then we'll set multi-cave, we'll set if we are at the end, and we will also add to the small caves if this is a lowercase value. The first one, where we are at start, we could make this a lot simpler, but I just add an empty set here, and then I will add this start value if it's lowercase, and it is probably, and at the end it will never be, and so on. But now we'll add to the path string. So this could have been much easier, but it's a copy-paste thing. Next up, we have this function where we check if we have been at the cave. So first off, we need to check if this is a lowercase value. If not, then we can visit as many of those as we want. But if it's a lowercase cave, we also want to check if this is a possible multi-cave. And if we haven't been at the multi-cave yet, this isn't the start or end position, and it's available in the visited caves, then we will return false, else we will return visited caves here. So that's the setup here in order to find if we have been at this position. We also have a function to check if this is a multi-cave, and it needs not to have been visited as a multi-cave before, of course. Should not be the start or end position, and it should be a cave that is already visited and is a small cave. Then we will return true, else it's not a multi-cave, so we return false. And then we have a bunch of these getters and also 2 strings, so we have easier debugging. So that was day 12. It was a lot of things to juggle with, classes and so on, but I think I figured it out pretty quickly. I had a few gotchas there. I hope that you learned something from this. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you solved this in a totally different way, leave a comment in the comment section down below. And I really hope to see you in the next video.